Hello my VOOP friends. In this video I will introduce you to the new Artlynk budget HD system from Betafpv and share my experience after testing it for a few weeks. Like any system, it has its pros and cons.
In this video, I'll briefly show you all the advantages and disadvantages so you can better decide whether this new budget HD system is right for you. And right at the beginning, I want to say that this system is not as good as the DJI HD system. But it doesn't have to be, because it is also significantly cheaper. The Artlynk HD system from Betafpv belongs to the new class of budget HD systems and should be compared within that category. All in all, I was personally impressed by how good the new Artlynk HD system from Betafpv is. The price-performance ratio is definitely good in my opinion. Of course, there are also some cons, which I will show in this video as well. The image quality is what you would realistically expect as a beginner at this price. I was definitely positively surprised by the image quality. The value for money is definitely there. The image quality is very good, especially if you don't fly far away and stay within about 50 meters of the pilot. At longer distances, or when flying in the forest, or in other challenging environments for video transmission, the image becomes somewhat washed out and blocky. I think this is clearly visible in the flight footage in the corresponding chapters of this video. So the video quality decreases the farther you fly, or the worse the signal becomes due to external factors such as objects between the goggles and the drone. Unlike DJI, where the center of the image remains sharp and the edges become blurry and blocky, the Artlynk system from Betafpv makes the entire image slightly blurry and blocky. The range of the video link definitely impressed me. Like all systems, there are limits that must be accepted. But within those limits, the video quality is very good. In an open field, the range in my test flights at maximum power of 200 milliwatts was around 400 to 500 meters, and that in all directions, forward, to the side of the pilot, above the pilot, and even behind the pilot. That was really impressive to experience. In addition, the loss of the video signal is very easy to recognize. That means the transition from a good video signal to a complete signal loss is gradual enough to react in time. That is very important and beneficial for beginner pilots. As mentioned, the entire image becomes somewhat blurry and blocky when the range limit is reached, unlike DJI, where the center remains sharp. The range when flying in the forest or in other challenging environments is of course significantly lower than in an open field, and can sometimes be as little as 50 meters, as you will see later in the corresponding chapter of this video. Compared to the Caddx Ascent system, and also the DJI system, the Artlynk system from Betafpv performs very well even in challenging environments for video transmission. The range of the DJI system is only slightly better because it has higher transmission power. But even DJI has its limits. With any video transmission system, you need to fly with caution and spatial awareness, whether analog, DJI, Artlynk, or Ascent. There is no miracle system. If you want more range in one direction, you can replace the two stock antennas on the Betafpv VR04 HD Pro Goggles with two 5.8 GHz patch antennas with RPSMA connectors. Most goggles use SMA connectors for 5.8 GHz antennas. Betafpv chose RPSMA for reasons unknown to me. Don't ask me why, friends. Ask Betafpv. The latency of budget HD video systems is relatively high, but still surprisingly flyable if you fly smoothly. There is definitely an adjustment period, especially if you are used to the very low latency of analog video links like I am. After a few dozen Lipos, you get used to the latency and learn what is possible and what isn't. Full send racing is definitely not possible, but relaxed flying is. Also, racing-style flying through gates and smooth freestyle. As long as you fly smoothly and anticipate your moves, latency is not a problem. In race mode, latency is supposedly a bit lower, but for me as an analog pilot, it didn't make much of a difference. With an HD system, I can never fly the same way as with my analog systems. I had to accept that. After that, it went quite well, and I only crashed rarely. But I definitely can't push myself. I had to constantly remind myself to fly smoothly and anticipate, and to hold back. That was a bit difficult at first, but eventually it was fine, and instead of the adrenaline rush, I just enjoyed the beautiful HD image. I can't say much yet about the durability of the system, since I rarely crash hard and often fly over soft ground. But I think simply due to the higher weight of the HD system, durability is lower than with an analog tiny whoop. In general, I would say HD systems are more for pilots who can control themselves and don't crash too often, especially not hard crashes. Small crashes are fine, but bigger crashes can definitely cause damage, especially if you are flying with large, heavy lipos like the Lava 2 680 mAh. From my perspective, HD whoops are definitely not bashers and should be flown and treated accordingly. The large, long lipos are also sensitive to damage. You should protect the ends of the lipos with a lipo condom made from heat shrink or a 3D printed part when flying over hard surfaces. The flight performance of the Meteor 75 Pro in the HD version from Betafpv is surprisingly good, thanks to some optimization by Betafpv. Unfortunately, this optimization is a secret. To this day, I don't know how Betafpv managed to get 20% more thrust out of the HD version compared to the analog version. And I really hope the next analog version will also have 20% more thrust. The power of the Meteor 75 Pro HD is definitely enough for all maneuvers and recoveries. The whoop feels solid in the air. The pilot is the limit. On my Meteor 75 Pro HD, I also applied Stabilant 22 contact enhancer to the motor connectors to reduce electrical resistance further. That is highly recommended, also to prevent electrical fretting, meaning contact corrosion, which the connectors of the Meteor 75 Pro tend to develop after a few hundred flights. That can lead to motor stuttering. I think Stabilant 22 helps prevent or delay this. The maximum indoor hover flight time is about 7 minutes and 45 seconds with a Lava 2 680 mAh Lipo from Betafpv using the CATA-X Ascent system at 25 milliwatts transmission power. At higher transmission power, flight time drops by about 5 to 15 seconds. In my racing style flights at outdoor temperatures of 12 to 18 degrees Celsius, I achieved an average flight time of 3 to 4 minutes with the Lava 2 680 mAh Lipos. That means a Lava 2 550 mAh Lipo is probably the sweet spot between flight time, power, and agility. Pilots who fly very slowly or want maximum flight time can choose the 680 mAh, and pilots who want maximum agility can choose 480 mAh. Personally, I would probably go with the 550 mAh. The difference between the VR04 HD Goggles and the VR04 HD Goggles Pro is easy to explain. The Pro version has a live feed output via USB-C with DP support, larger 18650 batteries for longer runtime, and removable 5.8 GHz antennas that can be replaced with RPSMA antennas. If you want more range in one direction, you can replace the stock antennas with patch antennas. As mentioned, most goggles use SMA connectors, but Betafpv chose RPSMA for unknown reasons. On my Pro version, rotating the camera image by 180 degrees did not work yet. This is important for those who want to mount the camera upside down for better cable management or other reasons. On the standard version, this rotation function worked. In my opinion, the head strap on both goggles is too short and I had to improvise with tape. Both goggles don't fit my head and face shape well, and there was a lot of light leakage. Overall, it's acceptable for such inexpensive goggles, but I personally couldn't fly for hours with them. I would rather pay more for goggles that are truly comfortable. But for the price, the Betafpv VR04 HD goggles are okay. Not great, but sufficient. On my second P1 Air Unit, the reception was very poor, which turned out to be caused by a defective stock 5.8 GHz antenna. I replaced it with a high-quality 5.8 GHz TBS antenna, and now the reception is perfect again. Use the chapters to navigate through the rest of the video. Some chapters are uncommented because they are self-explanatory. I hope you enjoy the rest of the video. A few words about the sponsors of this video: Betafpv, Stabilant 22 Contact Enhancer, Deox IT Contact Enhancer, and NPS Encore Contact Enhancer are the sponsors of this video. This video would not be possible without these sponsors, but this video would also not be possible without your support. Thank you very much for your support on Ko-Fi.com and through the affiliate links in the video description, as well as for your likes and comments that motivate me to keep going. Thank you, my whoop friends. appreciate it if you use the affiliate link in the video description for your order and for future orders. And if you would like to support my work further, I would appreciate a small donation on Ko-fi.com. The link is also in the video description. Thank you very much for your support, my Whoop friends. Flight times. The flight times of my Betafpv Meteor 75 Pro HD Ascent Whoop in combination with the 1-cell Lava 2 680 mAh Lipos and the modifications I presented in the Modifications and Weight chapter are very good. The flight time personally surprised me positively. The hover flight time is around 7 minutes and 45 seconds, with landing at 3.4 volts. I also do not recommend draining the Lipo that deeply every time like I did in the video. In this test, the Lipo was really completely empty after the flight. The recovery voltage of 3.64 volts after 10 minutes was a bit too low. Ideally, it would be 3.7 volts after 15 minutes. But 3.6 volts is also within the acceptable range for us Whoop race pilots. Our Lipos usually don't even make it to their normal end of life anyway, because they get externally damaged in crashes before that. Ideally, for the longest possible lifespan and many cycles, a recovery voltage of 3.7 to 3.8 volts, 15 minutes after the flight would definitely be best. Everyone has to decide for themselves where they set their priorities. By the way, the VTX transmit power has no major influence on hover flight time, maybe 10 or 15 seconds. I did the hover flight time test flights with 25 milliwatt transmit power. Also, during the comparison flights with the Analog 75 Pro Whoop, as well as the comparison flight with the CADX Protos. In the next chapters, you can also see the flight time during normal flights, which in my experience can vary between about 3 minutes during full send flying, around 5 minutes with a moderate flying style, and up to 7 minutes and 30 seconds when cruising calmly. It's like with a car. If you give a lot of throttle, you consume a lot of energy, and with less throttle, less. With tiny whoops, the range is quite large, roughly like a high-performance V8 engine that consumes 12 liters per 100 kilometers when driven economically, but can easily consume 80 liters per 100 kilometers on the racetrack. It's roughly similar with tiny whoops. Our tiny whoops are also high-performance machines. There isn't much more to say. If you still have a question about this topic, feel free to ask it in the comments of this video. Beginner freestyle flight. In this chapter, you see a flight with my Betafpv Meteor 75 Pro HD Ascent Whoop in a kind of beginner freestyle flight on a slightly windy day with an outside temperature of around 10 degrees Celsius. The performance of this whoop for this flying style is flawless. Flying in a predefined area no more than 100 meters away from the pilot's position so that video quality and latency remain in an acceptable range and the signal never drops out, allowing you to concentrate on practicing flight maneuvers. This is ideal for this whoop. There isn't much more to say. If you still have a question about this topic, feel free to ask it in the comments of this video. thrust test. There was a small surprise in the thrust test. This whoop has a secret, my whoop friends. For me personally, however, it was not a surprise, but rather a confirmation of my feeling after the test flights and of what I had seen online from other pilots. I quickly noticed already during the first flights that the Betafpv 75 Pro HD Ascent whoop has a better thrust-to-weight ratio than the Betafpv 75 Pro analog. But I couldn't explain why, and I still can't, because the motors are exactly the same size and same kV. The only thing I can do is show you the difference, which is very clear. The Betafpv 75 Pro HD Ascent whoop delivers almost 20% more static thrust, 19.3% more to be exact. That is a very noticeable difference that you can clearly hear and feel. The thrust-to-weight ratio with the Lava 2 one-cell 680 mAh Lipo is around 4.7 to 1 for the Betafpv 75 Pro HD Ascent whoop, with a takeoff weight of 51 grams and a static thrust of 241 grams, and around 4.2 to 1 for the Betafpv 75 Pro analog, with a takeoff weight of 48 grams and a thrust of 202 grams. The test setup was as follows. The kitchen scale used to measure static thrust has an accuracy of 1 gram. I performed the test on both whoops on the same day, indoors, at the same temperature of 22 degrees Celsius. And with exactly the same Lava 2 one-cell 680 mAh Lipo, which I charged freshly to 4.35 volts directly before each test, using the exact same charging port of the charger. On both whoops, I applied exactly the same contact enhancer to the motor connectors and pins. This is a modification that influenced the results of the flight tests. However, it affected both test whoops equally, since I applied the contact enhancer to both. Unfortunately, I can't reveal more yet, my whoop friends, because I may be developing a product for you. For now, I can only say this much. The flight tests, or more precisely the static thrust, were definitely influenced by the contact enhancer. I can't say how much yet, but it's more than some people think. I personally already know. I tested it extensively with multiple tests. A video about this will come within the next half year. Stay tuned, my whoop friends. I really can't explain it, my whoop friends. Why my Betafpv 75 Pro HD Ascent whoop delivers almost 20% more thrust with exactly the same motors as the Betafpv 75 Pro analog. It must be due to the ESC hardware. On the software side, the ESCs of both whoops are configured identically. If any of you have an idea, feel free to write it in the comments. Personally, I'm a bit puzzled. And yes, of course, I already reported everything to Betafpv and also asked whether the engineers at Betafpv are aware of this difference and how it can be. Betafpv wrote back to me that the engineers are aware of the difference, that it is intentional, and that how they achieved it is still a secret. That is, of course, a bit frustrating for me, but I understand it. In return, Betafpv always sends me the latest products. I can live with that. A little mystery has to remain. Otherwise, the excitement is lost. Just like with my contact enhancer project and a few other projects. Stay tuned, my whoop friends. Punchout Perfomance. The punch-out performance of my Betafpv Meteor 75 Pro HD Ascent whoop is surprisingly good. I really didn't expect that. But after my thrust test, I now know why that is. The power-to-weight ratio of the 75 Pro HD whoop is better than that of the analog version. For punch-outs, that is the only thing that matters. The punch-outs are absolutely acceptable for a one-cell HD whoop. I would even say very good. If you still have a question about this topic, feel free to ask it in the comments of this video. Washout behavior. I had no washouts during flights with my Betafpv Meteor 75 Pro HD Ascent whoop. Of course, it is possible with any whoop to provoke washouts by using too little camera angle and incorrect flying. But this whoop definitely does not have a washout problem. From my point of view, there is no tendency toward washouts. And that despite props in configuration. That surprised me. The whoop flies really very smoothly. There isn't much more to say. If you still have a question about this topic, feel free to ask it in the comments of this video. Modifications and weight. The most important modification I made to this tiny whoop, which influenced the results of the flight tests, was applying contact enhancer to the motor connectors. Unfortunately, I can't reveal more yet, my whoop friends, because I may be developing a product for you. For now, I can only say this much. The flight tests were definitely influenced by the contact enhancer. I can't say how much yet, but it's more than some people think. I personally already know. I tested it extensively with multiple tests. A video about this will come within the next half year. Stay tuned, my whoop friends. I hope I can soon offer you a solution for the problem with the motor connectors and for more power. The second and third modification are removing the rubber from the BT 2.0 connector and applying some E6000 or E7000 glue to save a bit of weight, as well as the obligatory securing of the motor wires to the duct struts with dental floss. These are the only modifications so far. The weight of the whoop is exactly 35 grams with this setup. In the future, I will also replace the steel motor screws with titanium screws and possibly also replace the screws that secure the canopy and the flight controller to the frame with titanium screws. There isn't much more to say. If you still have a question about this topic, feel free to ask it in the comments of this video. Problem with long lipos. The problem with long lipos is their durability in crashes. Flight time and performance are great with the large long lipos, especially the Betafpv Lava 2 680 mAh lipos. But it is important to know that these long lipos are very sensitive to crashes. Especially the front end of the lipo can get significantly dented in a crash, as you can see. And in this case, it was not even with the heavier 75 Pro HD whoop, but with the lighter Air 75 whoop. And it happened on the very first flight. That was very frustrating. Sometimes you can smooth the lipos back out and bend them straight again, but that is definitely not ideal. A lipo condom helps a bit, but even with that, these long lipos can bend significantly. Therefore, my conclusion is that these long lipos are only suitable for pilots who fly smoothly and do not crash often, or who fly over soft ground such as grass or rubber flooring on a playground. For full send flying over hard surfaces like concrete, it makes no sense from my point of view. In the end, of course, everyone has to decide this for themselves. But for me and my flying style, it makes no sense. Pro tip for long-lasting lipos. If you're flying over concrete and want to protect your lipos, use a lipo condom. You can make one from heat shrink, 3D print one, or cut one from a 2mm foam sheet. It doesn't matter how you do it. What's important is that the front of your lipo is protected in case of impact on concrete. To install the latest firmware on the goggles and the P1 Air Unit, you must first make sure that the P1 Air Unit is connected to the goggles. If not, you need to bind them first. If one of the devices has a different firmware version and binding is not possible, you must first update the goggles to match the firmware version of the P1 unit. Once the P1 Air Unit is connected to the VR04 HD Goggles, you can update both the goggles and the Air Unit at the same time. Make sure to set the transmission power to 25 milliwatts beforehand and cool the drone with a small USB fan or something similar to prevent overheating during the update. You can find the firmware files on the Betafpv website on the respective product pages. Scroll down on the product page to find the links to the latest firmware. Select the firmware you want and download the files to your computer. Then copy both firmware files onto a micro SD card that you have freshly formatted in the goggles. Insert the micro SD card into the VR04 HD Goggles. Turn on your drone and make sure it is connected to the goggles and that the battery is fully charged. Cool the drone if possible. Then start the firmware update in the goggles menu under Settings, System, and Upgrade. Wait patiently until the update is completed successfully. I would appreciate it if you use the affiliate link in the video description for your order and for future orders. And if you would like to support my work further, I would appreciate a small donation on Ko-fi.com. The link is also in the video description. Thank you very much for your support, my whoop friends.
Some additional information can be found in the video description. Please watch my many other tutorials on this YouTube channel if you want to know more about how to modify a tiny boop or how to learn FPV flying and racing.